In the following, we will attempt to create an application using a few pre-written Visinodes. The first Visinode dragged into Visifront is a short movie containing a spinning color calibration system, constructed and recorded using Visinode running locally under Linux. The video color sensor may be dropped into any element. It operates only if it finds itself over a video. This Visinode uses by default the built-in printing facility, vprint, of Visifront to report its discoveries. Please note how the vprint reading changes as the color sensor is dragged over each color. When the video color sensor is dropped into a Visinode that has no video element, it naturally stops reporting. Visifront has been set to prioritize coding, so with a right-click on a Visinode, the Edit Script option comes first. This option pops up a rudimentary coding window, meant to be used to modify the code element of Visinodes. The video sensor code is about as formidable as the Visinode code will get. Please don't be discouraged, most Visinodes are much simpler. The next step for our application is to create a visual display panel for the sensor reading. We can always decorate it later. Temporarily we will give it an outset border. Most important at the moment is to get all the elements of the application working properly. To represent the content level of the red color under the sensor, another Visinode is created inside the display frame and painted red. The new red Visinode needs to be linked to the sensor. To do this, the element is dragged and dropped into the code window, where it may be identified as a variable named o_clonable. From here on, the sensor element can modify our new red Visinode to the extent we permit. We do, however, need to add some JavaScript code to affect the Visinode dropped into the code window. The o_clonable is a so-called JavaScript DOM. It possesses the properties and attributes laid out by HTML and JavaScript rules. There is no need to know how it works, but rather, what it does. In this particular case, we intend to allow the color sensor to manipulate the height of our new red Visinode. Here, the o_clonable height is set to be the value of the red readout. The red variable comes as a numeric value, but the HTML web page requires a string. Therefore, the variable must be stringified to be understood by the web page. So numeric variable gets the toString suffix. The red variable in the vprint line has the suffix toFixed. Essentially, toString and toFixed are the same, except toFixed forces the variable to be displayed as an integer. It is good to be aware of the difference between number values and strings. Math cannot be applied to strings. The height of the new Visinode should change as the sensor registers the color within itself. We may have to extend the height of the display panel to accommodate the full strength of the sensed color. For the next step, we will attempt to activate the rest of the colors. To create a bar element for each color, the red bar is simply cloned to the right and painted accordingly. Then each bar is linked to the sensor element, the same way the red bar was previously incorporated. The o_clonable objects must be distinguishable, otherwise there will be disaster. We assign the first letter of each color to each element, and then we copy and paste the JavaScript line we wrote for the red color 2 times. The word red is replaced everywhere with the words green and blue. Same goes for the letter R. We set the sampling interval to 100 milliseconds or 10 samples per second, and then, we will do some testing. This video is produced using a 4-year-old computer. It is slow. To speed things up, it is better to record at lower resolution, and focus on Visifront only. Therefore, it is better to move from a portrait view to a landscape view, and then run the video recording. Right-click on the calibration video to bring up the context menu. The video can be looped, and if it is asynchronous, the speed may be increased to test the technical limits of the available system.